out of ultra-high performance, some of the connections where some projects have started to make their way through the architectural community, and market opportunities as we see them. One project that we're underway with right now, and how we may see such a change in this whole rain screen system from conventional precast that we're currently doing. Some of the challenges we've run into and some of the challenges we think we're going to still run into. How did we get started? Back in September of 2020, and then the material was being made in Europe. Larry was representing Lehigh at the time, and we brought a pallet or two in from Europe, and we started doing test batches. We are currently underway of trying to get permitted for this plant and working on some other projects, and we decided to take this challenge on at the same time, I guess. So we went through the process of how does it mix? What does it look like? How are we supposed to anticipate it? And anybody who's worked with it, you know, it turns into balls and it looks like it's never going to release. But once you get that product to a point where it becomes fluid, it runs very well, as some of you saw today. And so we started making samples, colors, adding colored aggregate, doing probably most things that the ultra-high performance people would cringe at, because we were doctoring these pre-made materials. But for us, if we couldn't get certain textures and colors out of it, then we didn't think we could sell it to the architectural community. Examples of form finishes, and I'm sure some of you saw, etches, polishes. At what point do the fibers become maybe too obvious to sell those as a quality product? So there are clearly some challenges that we've run through. The mock-up panel out back, we're not quite satisfied with some of the color, and so we're going to make some changes to that. But for us, it's still, you know, an ongoing learning process. It's now 3 years plus later, and we're still making adjustments and trying to figure out how do we get this to a point that we can further introduce it into projects architecturally. Our first job 2.5 years ago was Adidas was remodeling their headquarters downtown Portland, old wood structure, and it wouldn't be something that you could bring a 4 or 5 inch precast panel in, yet they wanted to match the CIP that was inside the building. It was kind of on the front of us even feeling comfortable producing these, and there were 4x8 sheets, inch thick, and so the question of how to attach it, we went to a grid system that we were familiar with somewhat already from a standpoint of stone, granite application. And the design of that was assisted by KPFF. It would require that we would have to drill rabbet connections to the back that the panels could hang off of. That grid system was 2 foot on center. And so when you get into a large panel job, the grid system and all that drilling becomes pretty labor intensive. And so we've leaned towards looking at French cleats, which is what we have currently on the mock-up panel. Example of we rented a drill press that works off of suction from the individual out of Florida that had been very involved in this process. And so you would lay out on the back of the panels, and then you would drill this dado in, and that would then be used to hook. Our engineer needed pull strips, so we made 10 12 by 12s, put the hardware in them, sent them back to the lab in Florida. They pulled them, showed the results, and so it was a bit of a process just getting the engineering to a point that KPFF would stamp it. So it was a relatively small job. I think there were 9 panels. The steel stud framer was familiar with the grid system, and they were under contract with the general contractor to hang these panels. I remember we sent the panels down there in 2 weeks, didn't hear anything. And so I said to Brittany, why don't you call and see what's going on down there? Next thing you know, we get a picture of the finished wall and we're done. So as always, no phone calls is best many times. And so these were just gray form finished panels. The market that kind of came to us, there was a dock contractor here at the Port of Tacoma, not far from where we're going to board tomorrow night. And he had been using the Arcus thin stainless steel stressed panels adjacent to the grid system of hot dip galvanized. And the requirement, at least in this area, is that you have to have so much area that the sun gets through and so much area that the sun can't get through. So when he's constructing these floating docks, he's alternating between a solid material and a grid system. He came to us for quite a while, 7 or 8 months, about we need to replace our vendor. We need to get somebody else to produce something. We weren't quite ready to start producing that kind of quantity of UHPC panels, but we moved into it. Last year we provided them with just short of about 800 panels. 1.5-inch panels. We don't have any spans over about 2 feet, based on steel substructure. They build them down there, install them at right off of their shop, which is in the water, and then they tow them out and install them at their customer, whether it's private docks or public docks or what have you. And they've got a lot of other projects in the next 2 years in the backlog, and so this was something we just kind of fell into. Texture is broom finish, so we're using a rubber mold and pouring face down. Easier than what you saw today. There are no riser sections in it. It's just a single face down. Example of a ticket. I think Roy touched on the fact that then the question is, how are we going to handle them? So at 1.5 inches, we went to a 1-inch tine and then basically use stainless steel because it's on the waterfront, welded to these, made mock-ups, sent them to a third party, had them test them for pull-out strength. And this time basically serves both purposes. We're pulling off the backside and then they're installing on the downside. Because it's on the dock, we talked about putting a plug in it. The owner of the company basically said, we don't need to plug them. They look fine the way they are. And so that's the way the process went for the rest of last year. Another advantage, of course, of the UHPC in saltwater is we've got no steel in it at all. An area that we do a lot of work in is stairs. And so for us, ultimately, we run into so many projects when the thinness of the stairs are a problem. It's our opinion that you can't put a stair tread in that's less than 3 inches. And you're fighting pre-designed contract drawings that sometimes have treads at 2.5 or even 2. So I would expect over the next year or so, we will bring UHPC into the stair market. We're not sure what that looks like. There was a 3-foot mock-up in the honing area, and obviously we've got to understand the best way to support that without getting it thicker, because the other problem so often with treads is they're hauling these 300-400 pound treads into a building that's somewhat begun to get finished, and they're figuring out how to get them hoisted onto the steel structure. Otherwise they're putting them in so early that damage can occur. So there's a lot of advantage to dropping that weight down to 75, 80 pounds. This is often, not often, but certainly occasionally a look that the architect is looking for, where both the underside and the top side runs at the rake and the run of the treads. With conventional concrete, we can't get there. And so we've made a few, but the throats get up in the 8-9 inch range just to be sound enough to be able to cut the bottoms out of them in the form process. And so we think in the future, clearly we're going to be able to do some things in the stair industry in general that's going to be very attractive and eye-catching to the architects. All of what you're seeing here has been produced already in Europe. And one of the hurdles here is getting engineers comfortable with the fact that there's no reinforcement in there. So if there's a failure, somebody's going to the ground. And so the industry as a whole, and it'll be addressed a little further tomorrow, we just don't have the standards out there at a level that engineers hang their hats on. And so, you know, what is that failure? When does it occur? How much weight is going to be applied when it occurs? And so our engineers at KPFF and the panels that you saw out there all have a single bar in them, partly just for that reason. Not that we probably need it, but to get a stamp, they want some secondary protection that that piece would not come off the building. Some examples of projects, again, out of this area in Europe where UHPC is 10 or 15 years ahead of us. And the thing we see is, how do these rain screen systems now work over top of a UHPC panel or any other kind of a standoff panel? We so often, when we're designing conventional precast, that conventional skin is meant to be watertight. And whether it's a spray foam back where you have access to the back of the panels, or it's a conventional panel going over top of a grain screen system, we're really looked at needing to be watertight. A few projects in the local area that at least UHPC became part of the conversation. The projects have not moved forward, but we're just starting to see that door open up where architects are looking at using it, or we've encouraged them to consider it where it seems like it would really fit into a job. This is one elevation of what will be the finished project from the mock-up outside. We have the luxury on this project that we're involved on ownership, and so therefore we can bring the product to the table and push it through the process of design and engineering and eventually installation. Here was an example of structural use of UHPC. And so gauge precast worked at removing interior columns, thinning up beams, and creating this much more usable space in an old existing building. And they had clear spans up to 69 feet. Now, most of these type of clear spans are coming with reinforcement. We've not heard of a pre-stressed UHPC beam yet, but certainly it's probably not far. This is a longest pedestrian bridge that was also built out of UHPC, Southern Canada. The US is such a litigious society that we are always towards the tail end of things coming into play where they've been used for 5 or 10 years already. Extremely attractive piece of work. So what are the barriers that we're kind of running into? Knowledge at the producer level. Even with us, we still feel like we're so far from really understanding how all this is going to develop. How are we going to make connections on so many different types of product? How are we going to help market it, sell it? And so the knowledge that we're hoping to share over the next 2 days is just really for the more people becoming familiar with it, more producers may be starting to use it, and eventually there's a lot of people who have been following UHPC for a long time who feel like we're really starting to go into that tipping point, that 2 or 3 years from now we're going to wonder how far it came quickly. Lack of standards. There was a push, as I understand it, and Anthony probably will touch on it a lot more tomorrow, where standards were starting to be developed, ACI, ASTM, and pandemic hit, it kind of got shelved. There are some standards that have been written, but still a long ways from where engineers can hang their hat on the fact that they've got standards to work with. Engineering itself, I mean, it makes them nervous. It's new, it's not fully tested. And so as long as we've dealt with our engineers at KPFF, it's a struggle to get them to get a little comfortable with even some of the more simpler things. Testing, a whole different level of testing, different types of equipment, different types of cylinder sizes, and just in general, it's got a long ways before it becomes somewhat common to us as producers. We've run into, we had a mold that shrunk, right? The form liner went in, Ango had set a chip in it. At midnight it was 145 degrees. It shrunk about 1/4 of an inch. And the form liner people say, at 140, all bets are off. And so we've got to start to rethink a little bit, okay, how are we going to handle that? If form liners can't handle the heat of ultra performance concrete, and form finish is sometimes one of the easier ones to use from a standpoint of exposure, then, and it might be that we pour one in a form liner, we flip it over, and then we use it as Nick does. We use that as our casting table, knowing it won't shrink. And money, the amount of money it takes to just continue to drive the process forward. We all have enough to do, enough places to use money, that you've got to be dedicated to the fact that you're going to keep plugging away, you're going to spend money. We have a job code where it's R&D because of the tax credit that's available when you go to R&D costs, and helps offset it some, but it's still a pretty strong commitment. Okay, any questions? Yes, sir. Why aren't we using steel fiber? We have not. Steel fibers would certainly help some of that process, right? In other words, you can hang your hat on steel fiber as far as a rupture goes, right? The rupture generally is that the fiber will break at some point, regular PVA fibers. The problem we have with it is that we can't really use it at the dock areas, right? Because we would show rust. Can't use it on anything that you're going to walk on in general, stair treads and so on, because of the potential for protrusion of that steel fiber. And the thing that we so often come in contact with is the etching for finishes. And so you can imagine what it would look like after we etched it. But steel fibers would solve one of the bigger problems that we have. Stainless steel fiber would be another thing, but the problem we have with stainless steel is at some point you will get some rust if it gets exposed to enough of it. So it would have to be a very specific project, maybe indoors, form finish, where the fiber wouldn't be exposed to touch. But that's mainly our concerns with steel fibers.
What problem is it solving?
The rupturing of the piece. At a point when you're testing it and it fails, the steel fiber generally won't do what a PVA fiber, it won't crack, break, and then the piece entirely fail. There'll be a tendency to hold it together. Yeah. Good answer? Okay. I'm stumbling my way through the engineering side, which I'm limited on.
You don't know any better, so.
Then I'll say it more persuasively, and you'll believe it's the truth.
So what about material handling in terms of warping and curling and that kind of stuff? I mean,
Good point.
What do you want to do to, once you get it out, what are the best processes you found in terms of handling?
So Anthony touched on this because we started to see some cupping, or not Anthony, Roy. And I don't know who brought this to our attention, but
I found it in the actual PCI
Great. So at the point that the piece has been set and just barely in place, by running this over the top and covering it with plastic quickly, the cupping stopped on our flat panels. So that was one. The other is we try to store and ship vertically. So we put them on end because of the same reason. At an inch or inch and a quarter, inch and a half even on dock panels, we feel like we'll get some creeping if they're sitting on just dunnage horizontally. So that's the other thing, is to get it on its edge line. Yeah, those are probably the two things we, at this point. Handling, we try not to put those pieces of hardware into shear, right? I've only got an inch and a half panel, maybe a 2-inch rib at best, and it just feels uncomfortable. We've tested pull strengths and shear strength, and it says it won't tear out of there, but you know, it's 600-pound panel, and so generally, once we trip it, we're carrying it out on its edge line, we're putting it into a rack on its edge line, and when it goes to the job site, it's going with that rack, and they're keeping it, they're not laying them down and tripping them back up. Yeah. And unfortunately, a lot of this you get stuck doing on your own, right? It's not like ALP's been all over ultra high performance and they can give you answers, right? It's making samples and testing 5 or 8, seeing what that range of pull-out strength is, then going back to a supplier like that and saying, well, here's what we're making and here's what we're testing. Are you interested in making it? And they have their own whole process that they've got to get to a level that they can stand behind it.
So that French cleat you guys have on that, is that kind of a proprietary system that you guys kind of developed internally?
Yeah, I mean, I'd like to say that, other than we've used French cleats in different, both in commercial masonry and some other type of stone cladding install. So we just kind of adapted it to ours. And then it was a process of discussing with KPFF, what are you comfortable with? How many tabs? How wide does it have to be? How much engagement has to be there? Now that project and that mock-up loads back to the foundation. So the French cleats there, although I believe they could clearly hold the panels on their own, are really just for pull out off the wall. The gravity load runs down and they're compression pads at quarter points to the base.
Have you looked at using pink ball instead of the gray ball?
Yes, and I think that's one of our next moves. The only reason we're not using it now, because it would float a little better, the galv bar, you got to tie it up or it'll fall into the mud, is we just haven't, I mean, we're buying galv bar on the truckload basis, and pink bar, we don't know what we'd do with a truckload for a while. But we do think that fiber bar is, whether it's Owings or whoever, it's clearly part of this, as well as the fiber mesh. I'm still not sure how guys get fiber mesh into an 1 1/4 panel where they want it. I mean, yeah. And there are companies that are making a lot of this material and chopping it up, right? They're putting fiber mesh in, layering it in, and then what size panel do you want, right? I'm not sure where that market goes, because what do you do with raw ends and all the other things, but Jamal. So this really was just Roy and the lead carpenter saying, hey, let's make something that, you know, will catch somebody's eye. And so they just built a form, poured it just for the show, honed it, polished it. But this is part of what we see. Where did Jen's slide go? I had a picture of your building in Denver, right? Which was GFRC, but it was a standoff. Rain screen was behind there. There was no intention to keep water from getting between the panel and the wall. And so connections were galvanized. The whole rain screen system was, you know, complete. And I think that's where we're going to end up seeing some of this thin material go, is on just standoff facades that have all kinds of architectural features, but have no intention of keeping rain out of the rain screen system. The rain screen system's been built to protect the building, and what goes behind it Now today, with most of the projects we do, we wouldn't think of telling the architect that water is going to get behind the system. They'd have a problem with that. Color consistency. With everything we do, we try to get there with aggregate. With UHPC, you really can't. And so you're either going to end up with a white-based, with most architectural precast, you're going to end up with a white-based mixed design or a gray-based. The rib wave panels out there have dye in it. And the struggle with me a little bit always with dye is just consistency of color. And so most of what we've produced up till now has been virtually no dye at all, and we live with either a light gray finished product or so often a white product. So we've experimented with a lot of samples, but we haven't tried to produce multiple panels. Now, the project in the mock-up will be a test to that because the charcoal color is clearly dye-based. And the water content is so super low that probably the variation won't occur. But we don't really know that until we really get into production. That and you know, how much colored aggregate can we put into a UHPC batch and not have it start to diminish the strength, the flexural and compressive strengths, because we've started to get outside of this fairly ideal particle packing that is what, between fiber and particle packing and admixtures and an enormous heavy cement content, that's really what generates the product. Yeah.
Just to the point of color retention, I'm curious if you've tried acrylic polymer or anything in the mix, which, similar to GFRC, can help with color retention.
Roy, what do you know about that? Is he here?
Repeat the question. Have you tried acrylic polymer in the mix? Repeat the question.
Okay, have you tried acrylic polymer in any type of form to create color? GFRC is driving there. I assume similar with some of what you do? Yeah.
No, I haven't. Yeah, short answer.
And so tell me, what's your reaction to that? I mean, it's similar material, right? It's high cement content, it's got fiber, it's all those kind of same things. You think we could easily find a very good color consistency with the use of it?
It may help, you know, but I don't know. Of course, test panels would be
right.
important, but Larry has.
So on those, they usually think that the polymer molecule is too big and that it interrupts the particle packing, so it'll affect your performance. That's been the conventional wisdom on UHPC in the past.
And is this liquid or powder?
Well, once they emulsify,
Liquid polymer will have a smaller particle than a dry polymer will.
Okay.
So I would be certainly trying a liquid polymer versus a dry.
that's been what they say is the issue. But you know, I don't know if it's been tested, but that's the conventional wisdom is that the polymer interferes with the particle packing, so you won't get the performance.
What would be your answers from a standpoint of color?
I don't know.
Okay. I mean, obviously, dry powder dyes we've utilized on some of this.
I've always thought, my thinking on it was always that a liquid dye would be perhaps better. But the problem is that there's so little liquid that it may not get good dispersion.
Right.
So if you get, the dyes, the particle size, you would want to kind of include that in your thinking of the particle packing. But it's the drier dye, you're going to get better dispersion.
Right. And that's kind of the way things are right now. It's pick at it, figure out an answer, try it, didn't quite work, try it again. Yeah. Okay, anybody else? Very good. Appreciate your attention. we've got a little time before the bus loads up. You're welcome to socialize, have another drink, relax, ask any questions. And again, we truly appreciate all the support, the attendance here. Thank you.
Good work, sir.
Thank you.